Hello friends, welcome to Insight X. This is a platform to learn about power transmission elements and its So friends, in today's video we are going to learn about transformer winding resistance test. Till now we have covered all the low voltage testing, voltage ratio, turns ratio, HV magnetizing current and balance test, short circuit test, LV magnetizing current and balance test, vector group test, and now in today's video we are going to see about winding resistance. So for winding resistance test we require a winding resistance. So this is how a winding resistance test kit looks like. Let us take a closer look to this and we will see how the operations are carried out in this test. So first of all, let us understand what is resistance and how it is. So the resistance is the measure of opposition to the flow of current. So we all know Ohm's law, that is V equals to IR. V is voltage, I is current measured in amperes, and R is resistance, that is measured in ohm. So how do we measure this resistance? So as per Ohm's law, if you want to calculate R, then the value of R is equals to V by I. Ratio of voltage to current gives us resistance. So suppose this is a resistance and resistor, and we do not know what is the value of this resistor, how much resistance is there in this. So let us do a little experiment. We have some voltage source over here, a switch is connected, and we will measure what amount of current is flowing through this. So let us do that. Let us turn on the switch, and 10 amperes current is flowing through this. So let us now measure what is the voltage across this two. So 50 volts is the voltage, okay, and based on the Ohm's law, now let us calculate the value of resistance. So 50 volts by 10 ampere will give us 5 ohms. Now for the transformers, we have a delta star winding in the transformer. So this is a general picture for delta and star winding. So this is more familiar and easier to understand. For delta winding connection, this is how the winding is connected. Okay, it doesn't have a neutral, but a star winding will have a neutral, as you can see over here. So when we are measuring anything for a delta connection winding, we have to consider in mind that the winding is divided between two phases. Say suppose we are measuring anything between R and Y, we will have all the three windings contributing to either voltage or current. Okay, and similarly if you are calculating resistance, you have to consider that equal based on the winding, the amount of winding resistance will be based on the mixture of all these three. But when you are talking about a star winding, for a single phase, say R to neutral, only one winding will come into the picture, right? So considering this in mind, now let us move further. See, this is the and you have, based on the same Ohm's law, V equals to IR, there is a provision for some amount of voltage and some amount of current that will flow. So this has the provision for two channels. You can see the winding over here. These are the voltage probes, and these two are the current probes. Okay, so this works basically on the very much similar principle. Now to operate this kit, you have the provision for earth provided over here. First of all, before using the kit, you always have to connect this kit to the earth. So that is for your own safety and also for the safety of the kit. So, and then it has various channels of operations, as this is channel 1 and channel 2. You can do different amperes and settings for resistance based on which type of winding you are testing. So now let us do the connections on this kit. So when we are doing the connections for HV side, on the HV side we are having the online tap changer OLTC. Okay, so when we are doing connections on the HV side, the winding for this transformer is a delta star winding. It is a delta on the HV side, So what we will do is we'll connect one for current channel. We will give a connection for R phase and Y phase. We have to measure the resistance because as I discussed earlier, the resistance is divided between two phases. Okay, so now we will measure for voltage. Again, for voltage plus and voltage minus, you will give the connections accordingly between R and Y phase. Now let us see how to take the readings for this. So we will make a table for noting down the readings of the test, and we have to make sure that while we are doing the test for HV side, we have the settings of 10 amperes and 2 ohm range inside the kit. Okay, and we will take this test on each and every tap because on different taps the resistance value will be changing. Okay, we will do the measurement as I said between RY, YB and BR phases. Okay, so let us take the test on the tap number 1. For tap number 1, as you can see between R and Y phase, all the 3 windings are coming into picture. Okay, we will now turn on the kit. Okay, and as you can see we have the settings of 10 amperes and 2 ohms over here. Okay, and when we turn on the kit and do the settings, we will get the value of resistance. That is 0.825 ohms, but we want to write it down in milliohms, so that will be 825.80 milliohms. Okay, similarly when the tap is on transformer step is changed to tap number 2, we will get the value as 0.820, that will be equals to 820 milliohms for tap 3 similarly, and for tap number 4. Okay, now we will have to change the connections between Y and B, and when we do the measurement, you can see on different taps we will get all these values, and similarly between B and R you can get these values. Now we will do this test on the LV side because on the LV there is only single winding, so we will connect a I plus probe to any one phase, let us say R phase, and negative will be connected for the neutral. Vice versa is also possible. Okay, and again for positive channel voltage and negative voltage, right? So both the reds will be connected on a phase and both the blacks will be connected on the neutral. So for LV side, our settings will be 1 ampere and 20 milliohms range, and for all the 3 windings, the winding is similar for all the taps, right? Because there is only single winding, so we will measure it on any tap, on any normal tap on which the transformer is normally kept on. So let us measure it for tap number 5. See, you can see over here single winding is there, right? Okay. For tap number 1 or 5, whatever you can measure, the result will remain always same. So let us turn on the kit and you do the settings of 1 ampere and 20 milliohms. So when you do this, you can get the result of 87.20 milliohms. It is already right. And similarly when we want to measure yn, you have to change this y, and you can turn on the switch and you can measure here, that is 8.25 milliohm. And for B phase similarly you will get 8.16 milliohms. So this is a conclusive table for all the results. Okay, so you can see that as the tap is increasing, my winding resistance is decreasing. So one way to check that your winding resistance or for on-load tap changing of the transformer is healthy is you have to see the consistent decrease in the value of its resistance in its milliohm range for all the 3 readings. Okay, and the same for the tap. On any tap you will get this similar kind of result for the LV side. Okay, so friends, that's all for winding resistance test. We will show how to conduct more tests on the transformer. Let us know if you have any queries in these videos, and also know how you like our series on transformer testing. Keep watching our videos. Thank you.